Hey guys, I've just been out at a job site today. That's the reason for the orange fluoro. But while I was there was an electronics store nearby, and it's this store here, Altronics. So I stopped in and I found an interesting product. It's this wireless energy monitoring system, and it's one of these little cheap 433 megahertz wireless systems. And it came with, in the box, this is a plastic box here. It came with a plug-in transmitter and then the receiving station. I'll show you the product page here. That's it there, and you can see that it was only $18. It was so cheap. And I also picked up, because you can buy the single GPO, this plug here, and then you buy the station with it, and then you also buy these separate little plug-in things like this. So I've purchased 2 of these. You can have up to 3 channels on it, and each of those, as you can see, were only $6 each. So all up with the 3 plug-in boards and the little LCD receiving station, I paid $30 Australian, which is very, very cheap. So I thought what we'll do today is have a look at the insides of this and see how accurate it is, and see exactly what functionality we can get from it and how it all works. So back on the product page now, you can see in the summary they sort of explain how it works, and you get these GPO or general power outlet plug-in devices, which then transmit voltage and power data back to this little base station, and you'd plug your appliance into this and then it allows you to monitor it. This LCD thing takes 3 AA batteries in the back, and it says it can go up to 30 meters range. Now that would be line of sight, and it's generally not that distance. We might have a chance to test that later. It also has temperature and humidity on the base station, and a clock and an alarm and some other little bits and pieces. So I found in the downloads here there's an instruction manual. So we'll click over to that now, and you can see this is by the company Powertron, and I think these guys sell a lot of this sort of, plug-in stuff. They also do transformers, power supplies, and bits and pieces like that. But basically, we'll have a look at the main functions. It's got clock, temp, humidity, line voltage, line current watts, kilowatt hours. Then it calculates greenhouse gas emissions. It accumulates the total kilowatt hours over the 3 circuits, I'm assuming. And it's got like total on time and a couple of prices, which I think would just be different tariffs for different times of day. So you can settle this up on this little base station. It will give you the readings on there. So most of these instructions I'm not going to go through. It's just sort of like how to link them together by pressing the link button, and they'll start communicating. So here are the specs. It transmits on 433 megahertz, which is very common for these little transmitter devices, wireless devices, domestic sort of stuff, little weather stations and bits and pieces. They're quite commonly 433 megahertz. They claim 30 meters in open space, maybe, don't know. So it says that it'll measure between 190 to 276 volts AC with an accuracy of plus or minus 1%. And the current range is 0.02 or 20 milliamps up to 10 amps, and an accuracy of plus or minus 1% or plus or minus 10 milliamps. And a power range of 0.5 or 2760 watts, which is basically your AC voltage multiplied by the amps. Again, plus or minus 1% or plus or minus 0.5 watts, and it'll count up to 9,999 kilowatt hours. So there's the stats. If I get a chance, I might just test some of those accuracies. I mean, these things are really built down to a price. I mean, for $6 for this, and they're still making a profit on that. And it's Australian retail store, which is generally quite expensive. So, I mean, that's impressive specs for such a cheap little device. But I'll quickly show you a close-up of the screen and the functions that it has, and then we'll do the usual, run downstairs and tear it apart. So here's the front panel for this device. You can see here it's measuring on circuit 1, designated by this here, and by pressing code I can go to circuit 2 and circuit 3. I don't have circuit 3 connected at the moment. I've only just connected 2 of the plug-in modules. So go back to circuit 1. So on this screen you can see it's got the current time, You can see also it's got the temperature here, and it'll flick between temperature and humidity. Now the temperature isn't really 27 degrees. I think it's just because I've been handling this unit and it sort of warmed up the case a bit. But if you let it settle, it will get back down to ambient. This is designed to sort of just hang on the wall or sit on a bench top and not really be handled. So you can see at the moment we've got our volts at 246 volts. And if I go here, you can see the mode and click through and see 0.26 amps. So at the moment this circuit, I just plugged it into the photocopier here at the office just to sort of have something with a bit of load on it. I plugged in my little laptop and stuff, and they basically draw very little power, so there's not a lot going on. See 57.7 watts. Nothing's counted up, nothing's accumulated on the kilowatt hours yet, or on the greenhouse gas. And now I can switch across to circuit 2, which is plugged into one of the PCs in the office here as well. You can see it's drawing 0.53 amps, 96.8 watts, and again it hasn't had enough time to accumulate any kilowatt hours or greenhouse gas. Now if I'm sort of sitting on the watts, I can just use the code key to click between the circuits and it will remember which mode I'm on, which is quite handy. All these other settings and things here are really just for like setting it up, so you press set and you can set the time and date. And price, you can go in and tell it how many cents and dollars and cents it equals, and how long the tariff goes for, and all those sorts of things. I'm not going to go into any of that detail. I mean, you can download the manual and read that for yourself, or purchase one of these if that's what you're interested in doing. I'm simply going to show the basics of this thing and test its accuracy, and then have a look at how it works inside. Something else worth mentioning, I've watched how often this updates, and I've looked at, say watts for example, and I timed it, and it looks like every, say, 40 seconds or so it gets a new reading come through, so it's not incredibly fast. You sort of only getting a reading once a minute or a little bit quicker than that, so it won't catch any spikes or anything crazy like that. It would be nice if it was faster, but it is what it is. It's sort of just meant to sit there on your bench top and take more long-term readings, I think. So yeah, that's sort of the resolution we're looking at. So I've come up with a very quick and simple way to test the voltage and current accuracy of this little wireless power monitor. I've got my Fluke clamp meter set up here, and I've got this little dodgy power board. And so what I do is I just clamp through the power here. I've just got it plugged into the wall, and I'm using channel 3 on this wireless device. So if you look over here, I'm looking at channel 3, and currently reading 240 volts and 239.7 over here, 240 on the Fluke. So the voltage range is very accurate. So now we'll test the amps range, and to do that I'm going to use this kettle, and I'm going to put it on just full boil mode, and I'll click the Fluke over to amps reading. So it's reading almost zero, 20 milliamps. That may just be for the internal circuitry of the kettle. And I'll move the mode to amps here on this device, so we're reading fairly close together there. And if I put this on full boil, that should click in. You can see the Fluke is now reading 9.3 amps. Just remember that our maximum amp range on this is 10 amps, so we're getting fairly close to that. This is going to take a while for it to update. This takes about 40 seconds or so to get a new reading. So there we go. So we've got 9.2, around about 9.2 amps on the Fluke, 9.27 on this device. So that's fairly accurate. So we'll let this update again for another comparison. Again, we've got 9.24 on the Fluke, 9.29 on this device here. So we're a little bit higher on this device, but I mean that's very close. That's surprisingly accurate. So I'm going to show a quick temperature and humidity comparison to test the accuracy of this device. You can see on this screen here, this is actually reading from this sensor. This is a building automation temperature humidity sensor, and it's very accurate. This little one here is just a cheapy eBay off-the-shelf thing, but has actually proven to be quite accurate as well. Now if we compare to this device, see it says 26.7 degrees. We can see over here it's 25.9. This one says 26. So we're about a degree off, about 0.8 degrees off of this, and I think that's within spec. I think the spec was plus or minus 1 degree. But the humidity range, see 63% humidity is way off. Over here we've got 51%, and then over here we've got 47%. And it's closer to the 51% there. This device here is I think plus or minus 2% tolerance. And so you can see 63% is just way off. This thing's been settling here for a long time too. I've had it up on this shelf just to sort of settle with these other sensors, and it's sort of found its happy place there. But it always tends to read the humidity way too high, but the temperature seems quite accurate. So here's the main unit, and obviously number 1 and 2 circuits. So what we'll do is we'll go through the base station first, I think. So we'll take the batteries out, and we've got a couple of Phillips screws in there. Okay, that's extremely basic. So we've got, obviously our RF module is here, and it's got a, I'll just zoom in on that for you. So you can see our RF module here, and it's got this slug here, and I'm imagine that that's to calibrate the 433 megahertz frequency that it's transmitting on. You can see it's like a single-sided board, and they just use these jumper links. So we'll turn that over. There's an LCD on the other side obviously, but we'll turn it over and see what's on the other side. They also have a 3.576545 megahertz crystal there by the looks of it, and this other crystal here next to it, the little this little cylindrical one, that's probably a like a 32.765 or whatever it is watch crystal for the onboard clock. Up here we've got, what's that, R2? That may be our temperature, like perhaps a thermistor of some sort, say a 10 kilo ohm or 47 kilo ohm thermistor. This here would be our humidity sensor, this little module here. And at the top, I'm not sure what that is there. I think this here might be a piezo buzzer that's used for the alarm. It does have an alarm function as well. And then obviously we've got the wires just coming across to the battery compartment on this side. It's really cheap plastic. Yeah, it feels pretty cheap, but yeah, so I'll just zoom you back out and we'll keep going. By the way, this big rail at the top here, it's like a metal rail. I'm assuming that's the antenna for this 433 megahertz wireless module. Oh, in fact, I just read it there, so it says antenna. So that's interesting. And that would be a specified length. That's probably a quarter wave. If you look at the wavelength of the 433 megahertz, you can calculate the wavelength based on the frequency, and then usually you need to like divide it into a nice number, say half or a quarter or on that sort of thing, to calculate the best antenna length. So it's tuned for that frequency. So I'm assuming that's what they've done there. That doesn't look quite long enough to be, well, I think 433 megahertz is around about 18 centimeters or so, so maybe it's half of that. That's about 9 centimeters, I suppose. Is that buzzer going to come out? Perhaps not. I'll just carefully turn this over. So you can see here the epoxy blob, and they'll have the silicon chip under there with the bonding wires going out to the PCB. They've used a zebra strip, which you can see here for the LCD module. And that correlates with this strip of contacts across here. And then we've got our key touch buttons here. And on this side there's just a couple of little passives, a bunch of capacitors along here, transistors and some other bits and pieces. Nothing amazing, right? Like, it's all very, very simple. I mean, all the smarts are obviously happening in this little microcontroller or piece of silicon here. And then they're just using this plug-in wireless module here to receive. I don't think this needs to transmit at all. I mean, to set up the devices, when you link the devices, you tell this that it has to listen, and then you go to the device like this, and then you hold down the set button, and then this starts transmitting. And I'm guessing that because you've told this to listen, it'll then pick up that this will have a unique ID. It'll then pick up the ID, and then off it goes. So there's no need for this board here, this main LCD board, to do any transmission at all. It's literally just receiving, and vice versa. These little plug-in boards only need to do transmitting. They don't need to receive. So they're like one-way wireless comms all the way through this system. So really, there's not a hell of a lot to look at there. It's all very basic, very simple. Let's have a look at one of these GPO modules. Take one of these apart, and we'll see what it looks like inside of that. So you can see this is just a simple GPO module. It's an Australian plug, which I think is the same as the Chinese plug actually. Chinese, I think they mount them the other way around, so the earth pin's at the top. But you can see it's just like a straight through connection. You plug that into your wall, plug your device into that, and then off it transmits the voltage and power and amps and all those sort of things. Looks like we've got 2 screws again. I can't feel anything under this label. So let's go for it. Okay, feels like it's got some clips or something there. What have I got? There we go. Okay. So that's what we got inside there. They've got a 2-board construction. One of them's doing, looks like a power supply board here, and then we'll have our comms here. Actually, this is interesting. You can see how they've done the antenna for this module. So this can here would be our 433 megahertz transmitter device. It'll be sort of like an oscillator of sorts. And actually, you can see it's got R433M written on top. But see the traces here, they're like little candy cane shapes with wires on the top and bottom. So on the other side of the board, I imagine it's got the opposite pattern. So it's literally like a spiral trace just coming from this end all the way down. That's so that they can get that length that I spoke about previously in a nice compact area, and they've taken the ground pour away from that, and then they've got their antenna trace just sort of looping backwards and forwards through the board. That's quite nifty. You can see they've got bits of glue and stuff. I'll just take off. This little push button here actually. You see that there? It says ADJ1, adjust 1. Interesting. Some sort of calibration of some sort. Screws are a little bit corroded and rusty, which isn't great, but oh well. Little crystal there, looks like another watch sort of crystal. On this side they've got big beefy shunt here. You can see that there would be the 10 amp current shunt, and then they'd be measuring that there. There's a little Atmel part there. 24028. Is that some sort of serial EEPROM perhaps? I'm not sure. Maybe that's storing its unique ID. Yeah, you can see how this board assembly is horrible. You can see these leads are just, capacitors are just laying all over the place. It's quite ugly. There's hot glue just all over the place. Corroded parts. It's all a bit horrible. Looks like they're using a capacitor divider perhaps for the power supply. Yeah, well, we'll take these screws off and we'll keep going, I suppose. So just 2 screws here. Oh yeah, this whole plug comes out, so that'll be so they can make different versions of it. There we go, we've got a little IC of some sort on that side. Sorry, I'll just get you zoomed in. I'll just turn this board over and we'll zoom in on that part. It's like a little Cirrus Logic part there. I'll put some details on the screen to identify that. You can also see they've got like a long line of resistors here in series. A couple of big diodes there. Some other bits and pieces. So this looks like a little micro, and perhaps that's got a little ADC in there and it's measuring that current shunt and the voltage and things like that. That may be what this is to do with over here as well. This long series of resistors is just like a voltage divider, so they can get a low enough voltage through a diode and things, and they can feed that into the chip as well and measure that. Then they have this ribbon coming from this board over to this other PCB with what looks like the RF board. I'll just take this board out, see if there's anything on the other side. There is an LED indicator or some sort of indicator that blinks from time to time, and I'm assuming that's blinking upon transmission. It also flashes fast when you're doing the linking this to the base station. Okay, so let's just take that out. Okay, yeah, you can see the button there, and that'll be where the indicator comes through. So that's your set button and then your little blinky light. So if we turn this over, so that's it there. We've got our LED, a whole bunch of passives and things, our epoxy blob there. I'm sort of thinking, I don't know about the Cirrus Logic parts, but maybe this is the smarts and that Cirrus Logic part is the ADC, like maybe a 2-channel ADC or something or other like that. Be interesting to look at those part numbers, but again, I'll put all the details on the screen here, so you guys should know what that is right now anyways. Yeah, it's a nifty little board. I mean, it's very poorly put together. I mean, it's $6, so it's very cheap. And you can see the way they've done that antenna, like I said before, it's like these little candy cane shapes. If you flip it over, you've got the opposite, so it's literally like the trace is going down here, going through the board on the via, going back, coming back, and it's literally spiraling all the way along to make the adequate length for the antenna, which is quite nifty. I haven't seen that done like that before. Have seen PCB trace antennas, but just not quite spiraled through the PCB like that. It's quite nifty, really. Thanks very much for watching, guys. I hope you find that interesting, and I may do a future video on this one because I'm curious about how they're transmitting the numbers and the formatting and things of their transmissions to send the voltage and current data. I've played around with like 433 megahertz remotes before and done projects where I reverse engineered and transmitted those sort of values. That was quite interesting. So if I do get around to doing that with this device, which is obviously transmitting some sort of analog values, I'll definitely do a video on it. But until then, thanks very much. Give us a thumbs up and see you in the next video.